be looking at the periodic table. Now, the periodic table, mainly looking at it from this chart. The chart is a chart of an element. The periodic table is a chart of an element showing the various arrangements of the elements in the increasing order of the atomic numbers. Okay, so we'll be looking at the periodic table with respect to the following. One, with respect to the brief history of the periodic table. Two, with respect to the periodic law, and with respect to how to use the electronic configuration to determine the group, the period, and the block. The period, the group, the period, and the block of the elements. It was Demetrius who first discovered, Demetrius Mendeleev, that first discovered this periodic table. What he did was to arrange the elements in the increasing order of the atomic mass. Because of what he did, there were lots of gaps in his table. For example, instead of carbon having 12 and 6 as atomic number, 12 as mass number, instead of using this 6 to arrange the elements in the periodic table, he was using this mass number. Because of that, there were gaps in his table. Though his table was able to accommodate some elements and was able to predict some other elements, but because of the arrangements of the elements in the increasing order of atomic mass, his table had a lot of. We'll be looking at the periodic law. Based on this, the periodic law states that the properties of the elements are a periodic function of the atomic. The periodic law once again states that the properties of the elements are a periodic function of the atomic number instead of their mass number. So that's all about the periodic law. So lastly, we'll be looking at how can we now use the electronic configuration to predict the group, the period, and the block of the elements. How to use the electronic configuration to predict the group, the period, and the blocks of the elements. Determine the group, the period, and the block of the following elements, e.g., okay, the following elements are sodium, number 2, carbon. Solution. So the first thing to do is to bring out the element sodium, and the atomic number of sodium is 11. The electronic configuration of sodium is 1s2, 2s2, 2p2, and 3s1. So how can we now get the group, the period, and the block of these elements? If to determine the group is very easy. All you need to do, this one S2 is shell, this one is L, and this is the N shell. So all you need to do is to count the numbers of electrons in the last shell. Look at this shell M. How many electrons are in the last shell? 1. Since it's 1, it belongs to group 1. Now, for the period is determined by the numbers of the principal quantum number, this x, the numbers of this s orbital in the electronic configuration. We have 1s, 2s, 3s. So therefore, it belongs to period 3. But if there were to be 1s, 3s, 1s, okay, 1s rather, 2s, 2p, 3s, and let me say like 3p and 4s, it will be period 4 because by then we'll be having 4 periods because of the 4s orbitals. But because this thing just have 1, 2, 3, it belongs to period 3. Lastly on this one, the block. The last letter in the electronic configuration determines the period. So the block here, let us get it. The last letter here is S. Since it's S, it belongs to block S. So let us confirm this on this periodic table. So we said sodium belongs to group 1. Okay, this is group 1 and this is sodium. It belongs to period 3. These are the period that are arranged in vertical order. This is period 1, period 2, and look at it, period 1, period 2, and period 3. Look at sodium. I will say belong to block S. Look at the block S. So with this, you can be able to predict the group, the period, and the block of this element. Let us go to carbon. For carbon, all you need to do is to write the electronic configuration. Carbon is C612, which is the atomic number, is what we are using. So it's 1s2, 2s2, and 2p2. Now the group, don't forget, we say to get the group you label first. This is K, this is L. Now we said that it is the numbers of electrons in the last shell that determines the group. The last shell here is L. How many number of electrons do we have on the L shell? 2 plus 2, which is 4. If here were just to be, for example, 2s, and is under L shell, the group will be 2 because it's just 2 on this shell. But since we have 2p also belonging to the L shell and is having 2, you add it together. So it will be 2 plus 2, which is equals to 4. So for the period is equals to the period. To get it is also easy. You count the numbers of orbitals in this electronic configuration, 1, 2. So you count the numbers of the s orbitals in this electronic configuration, 1, 2. So it belongs to period 2. While the block, it belongs to block P. Why? Because the last letter in this electronic configuration is P, therefore it belongs to block P. So once again, let us verify from our periodic table. We say carbon belongs to group 4. This is, okay, this is group 1, group 2, these are the D block. Group 3, group 4, look at carbon, group 4. It belongs to period 2, don't forget this is period 1, this is period 2, and this is carbon. And the block, look at it, is on the block P. So with this we are done with how to use the electronic configuration to determine the group, the period, and the blocks of the elements. So I will encourage you to try and do some of these other elements on your own, like magnesium, like potassium, like chlorine on your own. So with this we have come to the end of today's. So I would love to see how you determine the using the electronic configuration to determine the group, the period, and the block of this element, magnesium, potassium, and chlorine, on the comment section. So with this, we have come to the end of this video. Please like and subscribe. God bless you.